Hi everyone, welcome to this video where we'll dive into the first and most crucial step of any machine learning project, Exploratory Data Analysis, EDA. Today, we'll analyze a dataset for detecting ripe and unripe tomatoes, ensuring its quality and understanding its structure. Stick around because this is a vital step before training any YOLO model. Here's what the dataset looks like. Images folder contains the tomato images. Labels folder. Each image has a corresponding label file in YOLO format, which includes bounding box annotations and class labels for ripe and unripe tomatoes. We will examine the class distribution, visualize a few samples along with their annotations, and extract key statistics such as image dimensions and the number of images containing both ripe and unripe tomatoes. Let's dive into the code. First, we will import the necessary libraries required for the analysis. Then, we will load the images and their corresponding annotations using a load data function. Since all the images are in JPEG format, we will specifically look for .jpeg files for the images and .txt files for their corresponding annotations. To visualize a random sample of images, we create a visualize samples function. It uses matplotlib to generate a horizontal grid of sample images, with each image labeled as sample, followed by its index number and displayed without axes. Now, when we load the data and call the visualize samples function, we get a preview of the sample images. The dataset consists of images, and calculating their average dimensions is essential for optimizing machine learning models. The calculate average size function computes the average width and height of all images in the dataset. Once the average dimensions are calculated, the plot average size function visualizes these values using a bar chart for easier interpretation. Now let's see this in action. We'll call the calculate average size function and visualize the average image dimensions. Let's plot the class distribution to visualize how it appears in this dataset. To do this, we'll create the plot class distribution function, where we use 0 to denote unripe tomatoes and 1 to denote ripe tomatoes. Similarly, to count the number of images containing both ripe and unripe tomatoes, let's create a count mixed images function that takes a list of annotations as an argument. This function will count the mixed images. To visualize this, let's create a plot mixed images count function to display the results. Let's call these functions to visualize the class distribution and the images containing both ripe and unripe tomatoes. We can see that there is a significant number of mixed images in the dataset. Let's create a function called showSampleMixedImages to visualize the images that contain both ripe and unripe tomatoes. We can see that these images have both ripe and unripe tomatoes. We will create a function called showSampleMixedImages with bounding boxes to display mixed images with bounding box annotations indicating the locations of both ripe and unripe tomatoes. This function will load the images and their annotations and check for mixed images that contain both ripe and unripe tomatoes. If it finds any, it will randomly pick one and display both the original image and the annotated version with bounding boxes around the tomatoes. If no mixed images are found, it will simply let you know. Now, let's visualize the sample images with their respective bounding box annotations, with the original image at the top and the annotated image with bounding boxes at the bottom. Voila! We can now see the annotated images along with their bounding boxes. In this way, we can use various techniques to perform exploratory analysis on the given dataset to gain valuable insights.